Safety first, always, and of course. But hot baths reduce cortisol. Hot saunas reduce cortisol of a duration about 20 to 30 minutes is going to be beneficial. And of course, some of you may be interested in exploring the supplementation route. And for reductions in cortisol, really the chief player there is ashwagandha, which is known to decrease cortisol fairly potently. I should just warn you that if you're going to use ashwagandha in order to reduce cortisol, first of all, check with your doctor or healthcare provider before adding or subtracting anything from your supplementation or health regimen. Of course, I don't just say that to protect us. I say that to protect you. You are responsible for your health, what you take and what you don't take. Chronic supplementation with ashwagandha can have some not so great effects of disruption of other hormone pathways and neurotransmitter pathways. So the limit seems to be about 2 weeks of regular use before you'd want to take a break of about 2 weeks. So ashwagandha, again, a very potent inhibitor of cortisol, but with some other effects as well. Don't use it chronically for longer than 2 weeks. But if your goal is to reduce cortisol, let's say you're going through a period of increased irritability and aggressive tendency, maybe you're also not getting as much light as you would like, and perhaps also if there are other circumstantial things leading you towards more aggressiveness and your goal is to reduce aggressiveness, that can be potentially helpful. And in light of all this stuff about cortisol and estrogen and day length, I should mention that there are, in fact, some people who have a genetic predisposition to be more irritable and aggressive. And there are a couple of different gene pathways associated with this. We never like to think about just one gene causing a specific behavior. The way to think about genes is that genes generally code for things within our biology. In the context of today's discussion, things like neural circuits or the amounts of neurotransmitters that are made or the amounts of hormones that are made or the amount of neurotransmitter or hormone receptors or enzymes, etc., that shift the activity of our biology in a particular direction. They bias our biology. And in fact, there is a genetic variant present in certain people that adjusts their estrogen receptor sensitivity, and that estrogen receptor sensitivity can result in increased levels of aggression, sometimes dramatic increases. However, and also very interestingly, photoperiod, meaning day length, is a strong modulator of whether or not that aggressiveness turns up or not, whether or not that person with the particular gene variant is more aggressive or not, depends on how long the day is and how long the night is. One particular study that I like that references this is Trainer et al. The title of the study is Photoperiod Reverses the Effects of Estrogens on Male Aggression via Genomic and Non-Genomic Pathways. This was a paper published in the Proceedings of the National Academy of Sciences. We'll put a reference to this in the show notes if you'd like to explore it further. But it really points to the fact that rarely, sometimes, but rarely is it the case that just one gene will cause somebody to be hyper-aggressive. Almost always there's going to be an interplay between genetics and environment, and as environment changes, such as day length changes and the length of night changes, so too will the tendency for people with a given genetic variant to be more aggressive or not. Now, of course, in the absence of detailed genetic testing for this particular estrogen receptor variant, most people, I'm guessing you, are probably not walking around knowing that you have this gene or not. Regardless, I think it's important to pay attention to how you feel at different times of year, depending on whether or not it's summer, whether or not it's winter, whether or not you're getting sufficient sunlight, meaning viewing sufficient sunlight or not, whether or not you're getting sufficient sunlight exposure to your skin or not, whether or not you're indoors all the time. Generally, those things correlate with season, but not always. You can go through long bouts of hard work in the summer months when days are long, but you're indoors a lot and getting a lot of fluorescent light exposure late in the evening, and perhaps that's when you're feeling more aggressive. So we have to be careful about drawing a one-to-one relationship between any biological feature and certainly psychological or behavioral feature like aggressiveness. But it's, I believe, helpful to know that these genetic biases exist, how they play out. Again, they shift our biology in a general thematic direction. They don't change one thing. They change a variety of things that bias us toward or away from certain psychological and behavioral outcomes, and the various things that we can do in order to offset them. And we described those earlier in terms of trying to keep cortisol low by getting sufficient sunlight regardless of time of year and regardless of whether or not you happen to have this particular genetic variant. So earlier I talked about how it is testosterone converted into estrogen that's activating aggression in the ventromedial hypothalamus, not testosterone itself. However, there are some studies carried out in humans that have evaluated the effects of testosterone and how levels of testosterone correlate with aggressiveness in the short term. I'm just going to detail a few of those studies because I think they are interesting and important. First of all, there is a study that has explored levels of testosterone in men of different professions. Now, before I tell you the data, I want to be very clear here. With a study such as this, one never knows whether or not these men went into a particular profession because they had a testosterone level of a given value, or whether or not the work itself altered their testosterone levels, or both. And I think it's fair to assume that it's probably both. So be very careful in assuming that a given testosterone level is causal for choosing a particular career, or that a particular career is causal for creating a particular testosterone level. This study used salivary testosterone levels as the measure, which, to be fair, is not the best way to measure testosterone. Typically, blood draw would be the best way to measure testosterone, but nonetheless, provided the appropriate methods are used, salivary testosterone can be a reasonable measure of testosterone. The different occupations that were looked at were, and here they just looked at men in this particular study, were ministers, salesmen, they didn't say what particular types of salesmen, firemen, professors, of all things, physicians, and NFL players. And what they discovered was that the testosterone levels were essentially in that order from low to highest. So minister, salesman, fireman, professor, physician, NFL player. Now, we could microdissect all the different stereotypes and all the different features of each of these jobs. For instance, we don't know whether or not the fact that the firemen happened, at least in this study, to have lower testosterone levels on average than the professors or the physicians was because firemen have lower testosterone levels, or because they have a much more stressful job and their cortisol levels are higher than the professor or the physician. And cortisol and testosterone, not always, but generally are in somewhat antagonistic push-pull mode because they derive from the same precursor, et cetera. Typically, when cortisol is high, testosterone tends to be lower, and vice versa. So we don't know what's causing these effects. And again, this is just one study and just 6 occupations. But I think it's relatively interesting given the fact that each of these professions involves different levels of competitiveness, right? So we don't necessarily just want to think about the level of physical exertion that's required, but also the level of competitiveness, because it's known that competitive interactions can cause increases in testosterone, in particular in the winners of competitive interactions, a topic for a future podcast. Meanwhile, studies that have analyzed also, again, salivary testosterone in prisoners, in this case, female prisoners, so these are incarcerated individuals, have looked at levels of testosterone according to whether or not the person committed a nonviolent or a violent crime in order to arrive in prison, and higher levels of salivary testosterone were related to those that had arrived in prison because of conviction of a violent crime as opposed to a nonviolent crime. Likewise, when they analyzed prison rule violations, so an indirect measure of aggressiveness, but in this case it was strongly associated with aggressiveness because they knew what the violations were, they found were for prisoners that had no prison violations, prison rule violations, I should say, their testosterone levels tended to be lower than the testosterone levels of women that had some, even one or more aggressive violations of prison rules. We'll provide links to these studies in the show notes if you'd like to go into them further. Obviously, studies like this need to be taken with a grain of salt because there are so many different factors. Different prisons have different degrees of violence to begin with and competitiveness to begin with. But just as a final pass at examining the role between testosterone and aggressiveness, there was a very interesting study from Goetz et al., Goetz, published in 2014, that looked at serum, so in this case, blood levels of testosterone, 30 minutes after application of a gel-based testosterone that goes transdermal, so that the testosterone can go very quickly into the bloodstream, and then did brain imaging to evaluate the activity of neurons in the so-called corticomedial amygdala. The medial amygdala is one of the areas of the amygdala complex, as we call it, because it's complex. It's got a lot of different nuclei. You now know what nuclei are, little clusters of neurons. It's got a lot of different ones, but that medial and that corticomedial amygdala in particular is known to be associated with aggressive type behaviors. It's linked up with, is part of the larger circuit that includes the ventromedial hypothalamus and other brain areas that we referred to earlier, such as the PAG. What is remarkable about this study is that it showed that just 30 minutes after application of this so-called androgel, this testosterone that seeps into the bloodstream, there was a significant increase in, of course, testosterone and corticomedial amygdala activation. So testosterone can have acute effects, immediate effects on the pathways related to aggression. And I think this is something that's not often discussed because many of the effects of steroid hormones like testosterone and estrogen are very slow acting. In fact, steroid hormones, because they have a certain biochemical composition, can actually pass through the membranes of cells, so the outside of a cell, and into the nucleus of the cell and change gene expression in the cell. You think about puberty, the kid that goes home for the summer and then comes back looking completely different. Well, that's because of a lot of genes got turned on by steroid hormones like testosterone and estrogen. But the steroid hormones can also have very fast-acting effects. And with testosterone in particular, those can be remarkably fast-acting, and one of the most apparent and well-documented fast-acting effects is this effect, the ability to activate cells within the amygdala. So you might say, well, I thought the amygdala was associated with fear. Wouldn't testosterone then cause fear? No. Turns out that the amygdala harbors both cortisol, corticosterone receptors, and testosterone receptors, and they each adjust the activity in the amygdala differently, such that testosterone tends to activate amygdala circuitry for inducing states of mind and body that are more action-based. And indeed, in animals and in humans, testosterone application and activation of this corticomedial amygdala pathway will make animals and humans lean into effort. This is why I say testosterone makes effort feel good, or at least biases the organism toward leaning into challenge. So if you recall, there's not just one type of aggression. There's reactive aggression, which is triggered when one is confronted with something that sometimes is inevitable, right? One needs to fight for their life or for somebody else's life, but also proactive aggression. And proactive aggression involves activation of those go pathways in the basal ganglia and a leaning into effort to overcome whatever state one happens to be in to begin with. And so this is very important because it points to the fact that, yes, estrogen is activating aggression pathways that are in the ventromedial hypothalamus, but it's very likely the case that testosterone is acting to accelerate or to bias states of mind and body toward those that will lead to aggression. Again, aggression is not like a switch on and off. It's a process. It has a beginning, a middle, and an end. Remember that hydraulic pressure that Konrad Lorenz hypothesized? Well, think of testosterone as increasing the pressure toward an aggressive episode, and then estrogen actually triggering that aggressive episode in the ventromedial hypothalamus. So if somebody tells you that testosterone, endogenous or exogenous, makes people aggressive, tell them no. Testosterone tends to make people lean into effort, and if that effort involves being aggressive, either reactively aggressive or proactively aggressive, well, then it will indeed lead to aggression, but the actual aggression itself is triggered by estrogen, not testosterone. Now, thus far, we really haven't talked too much about the social context in which aggression occurs. And that's because there is a near infinite, if not infinite, number of variables that will determine that. So, for instance, violent aggression is entirely appropriate at a professional boxing match, provided it's occurring inside the ring and only between the competitors and within the bounds of the rules of the sport, etc. However, there are some things that tend to bias certain social contexts toward being more aggressive or less aggressive, and not always physical aggression. And those generally come in two forms that many of you are familiar with, which are alcohol and caffeine. Let's discuss caffeine first. Why would caffeine increase aggressive impulsivity? Well, the general effects of caffeine are to increase autonomic arousal, the activity of the so-called sympathetic arm of the autonomic nervous system, which is, to put it very much in plain language, it's the alertness arm of your nervous system. That is, it creates a sense of readiness in your brain and body, and it does so by activating the so-called sympathetic chain ganglia. Again, as I always remind people, sympa and sympathetic does not mean sympathy. Sympa means together or all at once, and caffeine tends to bias our brain and body to activate the sympathetic chain ganglia, which run from about the base of your neck until the top of your pelvis, and deploy a bunch of chemicals that jut out into the rest of your body, activate adrenaline release. There's a parallel increase of adrenaline in your brain, creating the state of alertness and readiness. That state of alertness and readiness can be for all sorts of things, not just aggression. However, when we are in a state of increased sympathetic tone, meaning more alert, such as after drinking caffeine, we will bias all those brain and body systems, the hormones, the chemicals, etc., that exist toward action as opposed to inaction. So put simply, caffeine can increase impulsivity. No surprise there. On the opposite end of things, alcohol tends to decrease activity in the sympathetic arm of the autonomic nervous system, tends to make us feel less alert. Now, initially, it can create a state of alertness because of its effects in inhibiting the forebrain. Our forebrain prefrontal cortex in particular has what's called top-down inhibition. It exerts a inhibitory or a quieting effect on some of the circuits of the hypothalamus, such as the ventromedial hypothalamus. The way to conceptualize this is that your forebrain is able to rationalize and think clearly and to suppress behavior and to engage the no-go pathway. It's telling you, don't say that mean thing, don't do that violent thing, etc. Alcohol initially tends to increase our level of overall activity by reducing inhibition, not just in that forebrain circuit, but in other circuits tends to make us more active. We tend to talk more than we normally would, move more than we normally would, but very shortly thereafter starts acting as a sedative by way of reducing activity in the forebrain, releasing some of the deeper brain circuits that are involved in impulsivity, but also causing a somewhat sedative effect. And then, of course, as alcohol levels increase even further, people eventually will pass out, blackout, etc. So what we've got with alcohol and caffeine is we've got two opposite ends of the spectrum. Caffeine increasing arousal and readiness and the tendency for impulsivity, and alcohol also increasing impulsivity, but through a different mechanism. A really interesting study, and I should just mention that the title of the study is Caffeinated and Non-Caffeinated Alcohol Use and Indirect Aggression, the Impact of Self-Regulation. So the title is almost self-explanatory. This was a paper published in the Journal of Addictive Behavior in 2016, examining how ingestion of alcohol that's either caffeinated or non-caffeinated alcohol drinks impacted what they call indirect aggression. And just to remind you what indirect aggression is, these are not physical acts of aggression, these are verbal acts of aggression. So embarrassing others or otherwise somehow trying to reduce the well-being of others by saying certain things, in particular in groups. This study examined both males and females. This was done by way of a college campus study. Subjects were 18 to 47 years old. I guess there's some older students on that campus, or maybe they use some non-students. But, these days you've also got some students that are in their 30s and 40s. So they have a fairly broad swath of subjects included, fairly broad racial background as well. Included not at equal numbers, but at least they included a pretty broad spectrum of people with different backgrounds. They looked in particular at people that ingested non-caffeinated alcohol drinks at a frequency of 9.18 drinks per week. Okay. Again, there's a college campus. Not that I encourage that. I'm one of these people that I've never really liked drugs or alcohol, and it's sort of fortunate in that way. I can drink or not drink and tend to not drink. But so to me, 9.18 drinks per week sounds like a lot, but I know for some people that might actually be typical. And then others who were drinking at least one caffeinated alcoholic beverage per week. And those individuals, and as high, I should say, as 7.87 caffeinated alcohol beverages per week. So this would be energy drinks combined typically with hard alcohol that's fairly commonly available in bars and so forth. And some individuals drank as much as, 20.36 alcoholic drinks per week total, some that were caffeinated, some that were not caffeinated. The basic outcome of this study was that the more alcohol someone tended to consume, the more likely it was that they would engage in these indirect aggressive type behaviors. And in terms of the caffeinated alcoholic beverages, there the effect was especially interesting. Here I'm just going to paraphrase, or I'll actually read from the study. Quote, with regard to caffeinated alcoholic beverage use, our findings indicated that heavier caffeinated alcohol beverage use was associated positively with indirect aggression, even after considering one's typical alcohol use and dispositional aggression. What this means is that even though alcohol can bias certain individuals to be more aggressive, and even though certain individuals already have a disposition toward being more aggressive, there was an effect that was independent, meaning above and beyond both alcohol and a predisposition, meaning if someone was consuming caffeinated alcoholic beverages, they had a particularly high likelihood of engaging in indirect aggressive behavior. Now, this makes perfect sense in light of the model they propose, which is this self-regulation model that basically self-regulation involves several things. It involves engaging in certain behaviors and suppressing other behaviors. So as described before, because alcohol tends to have a sedative, suppressive effect on the autonomic nervous system, at least after the initial period, it's going to tend to reduce the likelihood that people will engage in any type of behavior, whereas caffeine will increase autonomic arousal and increase the likelihood that someone will engage in a particular type of behavior, aggressive or otherwise. So the combination of caffeine and alcohol is really acting as a two-pronged system to bias people towards more impulsivity, that is less self-regulation. So it's really yanking your volitional control, your ability to engage in prefrontal top-down inhibition over your hypothalamus from two distinct and specific circuits. By now, you should be getting the impression that self-regulation is a key feature of whether or not somebody, maybe even you, is going to engage in aggressive speech or aggressive behavior. And we've talked about a number of tools that one can use to reduce the probability that that will happen. I suppose if the context were appropriate, you could even take those tool recommendations and just invert them and increase the likelihood that aggressiveness would happen. But regardless, self-regulation is key. And in light of that, I want to share with you a study that's focused on kids, but that has important ramifications for adults as well. As you probably are already aware, there are many kids out there that suffer from so-called attention deficit hyperactivity disorder, or ADHD. There are also many adults we are finding that are suffering from ADHD. And there's also an epidemic, I would say, of people that are concerned about whether or not they have ADHD. Now, whether or not they have true clinical ADHD or not is not clear. We did an episode all about ADHD and tools for ADHD. I would encourage you to check out that episode and some of the diagnostic criteria. If you have the opportunity, you can find that at hubermanlab.com. As this study I'm about to share with you aptly points out, there is no objective diagnostic marker of ADHD. There's no biomarker or blood draw or blood test for ADHD. Whether or not one has ADHD depends on their performance on a number of different cognitive tests and behavioral tests and self-report. In any event, the study I'm about to share with you explored how a particular pattern of supplementation in kids with ADHD was able to reduce aggressive episodes and impulsivity and increase self-regulation. And the title of the study is Efficacy of Carnitine in the Treatment of Children with Attention Deficit Hyperactivity Disorder. Even though they put carnitine in the title, that what they focused on was whether or not acetyl L-carnitine supplementation could somehow adjust the behavioral tendency of these kids with ADHD. And to make a long story short, indeed, it did. There was a very significant effect of acetyl-carnitine supplementation on improving some of the symptomology, of ADHD. A few details about this study that might be relevant to you. This was a randomized, double-blind, placebo-controlled, double crossover study. This was done as an outpatient study, so the kids weren't in a hospital. They were living out in the world. This, again, was done on younger kids, so this was 6 to 13-year-old kids that were diagnosed with ADHD. They received either acetyl L-carnitine or placebo, and they did all the good practice stuff that good researchers do of making sure that the placebo and the acetyl L-carnitine had similar look and taste. It was consumed twice daily after meals. I should just mention that acetyl L-carnitine typically is taken in capsule form or occasionally in injectable form. Here, they were using this as a drink, which is essentially the same as capsule form, but the powder is just going directly into liquid. And the carnitine dosage was 100 milligrams per kilogram. So they're doing this according to the body weight of these kids, with a maximum dosage of 4 grams per day. The quantity of the medication was supplied, here I'm reading, for a period of 8 weeks, and every 8 weeks a new quantity of medication was supplied. So basically this is a fairly long-term study exploring behavioral outcomes and psychological outcomes in week 8, 16, and 24. They also looked at things that you could only get through a blood draw, so things like hemoglobin, hematocrit, red blood cell count, white blood cell count, et cetera. These are kids, and even if it were adults, they were quite appropriately examining a lot of the physiological measures that one would want to carry out to make sure, first of all, that blood levels of carnitine are increasing, and indeed they confirm that, but also that no negative effects are showing up in the physiology as well as the psychology of these kids. So first I'll just tell you the basic outcome of the study, which was, here I'm paraphrasing, given twice daily, carnitine appeared to be effective and well-tolerated treatment for a group of children with ADHD. They showed significantly abnormal behavior compared to these other boys. And now I'm moving to the table of results. They showed significant reductions in their so-called total problem score. The total problem score is a well-established measure of behavioral problems in kids with ADHD, and I should say adults with ADHD. It has to do with challenges in social and learning environments and how well or poorly an individual tends to perform, reductions in attentional problems overall, reductions in delinquency, and most important for sake of today's discussion, significant reductions in aggressive behavior. Now, what's especially nice about this study, I think, is that even though it's a relatively small number of subjects and certainly needs to be repeated in other studies and other laboratories, that they were able to confirm the shifts in L-carnitine within the bloodstream of these kids. That is, they were able to correlate the physiology with the psychological changes. You know, in studies like this, and frankly, in all studies of human pharmacology, you have to worry about effects that show up, not just because of placebo effects, but because of so-called off-target effects or related to things totally independent of the drug or the particular supplement that you happen to be looking at. To put in the words of a great neuroscientist, unfortunately he passed away some years ago, but he was a member of the National Academy, extremely accomplished neuroscientist, once turned to me and said, "Never forget, a drug is a substance that when injected into an animal or a human being creates a paper." Meaning you can see effects of pretty much any drug or any supplement in most all conditions. However, it is in cases such as this study where you can quite convincingly see that the particular feature of physiology that you expected to change actually changed. And you see a psychological outcome that you can gain much greater confidence that the changes in delinquency, in this case, reduced delinquency, improved attention, reduced aggressiveness, and so forth, was at least somehow related to the shift in blood physiology and levels of L-carnitine or acetyl L-carnitine and carnitine in the bloodstream of these children, as opposed to something else like L-carnitine going and affecting some downstream target that you have no knowledge of. Now, of course, that's still entirely possible, but I think studies such as these increase our confidence that things like L-carnitine can be used perhaps in concert with things like omega-3 supplementation, diets that are biased towards increasing more tryptophan and therefore more serotonin, obviously avoiding things like alcohol, and as it appears from the study I just described, reducing one's intake or not consuming any caffeinated alcoholic beverages. Seems like it would be a good idea if your goal is to reduce aggressiveness, to think about the hormone context and whether or not you tend to have higher testosterone and estrogen or lower testosterone and estrogen. Maybe even think about the work environment, whether or not you are existing in a particularly competitive work environment, and even day length, time of year, and whether or not you're getting sufficient sunlight, whether or not you're avoiding light in the evening, and so on. So studies such as this, I think, are useful because they point to the fact that very seldom, if ever, will there be one supplement or one nutritional change or even one behavioral change that's going to completely shift an individual from being aggressive and impulsive, but rather that by combining different behavioral regimens, by paying attention to things like time of year and work conditions and school conditions and overall levels of stress and likely, therefore, levels of cortisol, et cetera, that you can use behaviors, diet, and supplementation as a way to shift that overall internal milieu from one of providing a lot of internal hydraulic pressure, as it's been called throughout the episode, toward aggressive impulsivity and relax some of that hydraulic pressure and reduce aggressive tendencies. So once again, and frankly, as always, we've done a deep dive into the neurobiology and the psychology of what I believe to be an important feature of our lives, in this case, aggression. I want to point out that in an episode in the not too distant future, I'm going to be hosting Professor David Anderson from Caltech University, who is the world expert on the neurobiology of aggression. In fact, he is the senior author on many of the studies related to the ventromedial hypothalamus that I discussed today. Our discussion will touch on aggression, of course. So hearing today's episode will help you digest that information, but we are also going to talk about other emotional states. He is an expert not just in aggression, but in motivated states related to sex and mating behavior, social relationships of all kinds, and how those relate not just to biology and psychology, but also certain forms of pathology, things like PTSD and the relationship, for instance, between anger, fear, anxiety, and depression, and many other important topics that I know many of you, if not all of you, will be interested in. In the meantime, I want to point you to his recently released and wonderful book entitled The Nature of the Beast, How Emotions Guide Us. And again, the author is David Anderson from Caltech. This is a wonderful book. It serves as a tremendous introduction to the history of the study of these areas, the current science and discoveries being made in these areas, all made accessible to the scientist and non-scientist alike. It's a very engaging read, and so much so that even though he was gracious in sending me a copy, I also purchased myself a copy to give to somebody who is a therapist, and I've purchased another copy to give to a high school kid that I mentor because he's very interested in the neuroscience of emotions, and I think we are all interested in emotions, not just fear and some of these negative states, not just aggression, but also the positive emotions of our lives. And so The Nature of the Beast, How Emotions Guide Us by David Anderson is a wonderful read. I can't recommend it highly enough. If you're learning from and or enjoying this podcast, please subscribe to our YouTube channel. That's a terrific zero-cost way to support us. In addition, please subscribe to our podcast on Apple and Spotify. And on Apple, you have the opportunity to leave us up to a 5-star review. Also, if there are any episodes of the podcast that you particularly like, please share them with others. And if you have suggestions about particular guests or topics that you'd like us to cover on the podcast, please put that in the comments section on YouTube. We do read all those comments. Please also check out the sponsors mentioned at the beginning of today's episode. That is the best way to support this podcast. We also have a Patreon. It's patreon.com/Andrew Huberman. And there you can support the podcast at any level that you like. During today's episode and on many previous episodes of the Huberman Lab podcast, we discussed supplements. While supplements aren't necessary for everybody, many people derive tremendous benefit from them for things like improving the transition time and the quality of your sleep, and improving alertness and focus, and so on. Anytime you're considering taking supplements, there are several key considerations. First of all, those supplements should be of the very highest quality, and you want to make sure that what's listed on the bottle is actually what's in the bottle, which is a problem for many supplement companies out there. The Huberman Lab podcast is pleased to announce that we are now partnered with Momentous Supplements because we believe Momentous Supplements to be of the very highest quality of any supplements out there. And we've been working very closely with them in order to direct them to create supplements that are individual ingredient supplements of the particular quality and sources that we would like to see and that relate to the science and studies covered on the Huberman Lab podcast. If you'd like to see some of those supplements, you can go to livemomentous.com/Huberman, and there you will see some of the supplements that we've talked about on this podcast before, such as magnesium threonate for augmenting sleep, things like L-tyrosine for augmenting dopamine, and things like L-carnitine, which we've discussed on today's podcast. Right now, the list of supplements and the products that are there is only partial to what will soon be included in the future. So that's an ever-expanding catalog of, again, what we believe to be the very highest quality supplements available to you. For those of you that are interested in behavioral, nutritional, and supplementation-based tools for neuroscience and other aspects of your biology that impact your health and performance, we have a newsletter. It is a zero-cost newsletter. It's called the Neural Network Newsletter. You can go to hubermanlab.com, and there in the menu, you'll find the Neural Network Newsletter sign up. You can just put your email. We do not share your email with anybody else. You will also find examples of the newsletter that you can download right away without having to sign up and decide if signing up is right for you. And if you're not already following us on Twitter and Instagram, we are Huberman Lab on both Instagram and Twitter. And at both places, I describe science and science-based tools, some of which overlaps with the content of the Huberman Lab podcast, but much of which is distinct from the content of the Huberman Lab podcast. Once again, thank you for joining me for our discussion about the biology, psychology, and actionable tools around aggression. And as always, thank you for the progress to emerge. But that doesn't necessarily mean being antisocial. You can invite people along. But in this case, I'm telling people to be the host, not the guest.
I have a little bit of a rule here. Maybe I should have answered your question this way. I actually like doing things totally different occasionally. So when I'm traveling, I tend to do hotel workouts. What I mean by that is I will go down to the workout room and I will do a set of 10 to 15 reps of every single machine in the exact order in which they are laid out.
Whoa.
Just for the sake of fun. Like just for the sake of
it's like the tarot card version of workouts.
Yeah, totally.
It's like whatever comes up, I'm going to make sense of it. Right?
And you just move.
Yeah.
And those are typically things of like, I just want to move a little bit for jet lag and other sort of purposes, right? That's often like, I wasn't going to get to work out today. And so now I'm going to do something to feel great. I don't travel that much though. So it's not really throwing my things off. I don't get a lot of free time. And so if I am traveling and I'm seeing someone I haven't seen in many years, or for the first time, I mean, we got to train together this week for the first time. I'm not going to burn that opportunity. My rule is this though. I'm not going to do something that's going to cost me more than 3 days. So I'm absolutely happy to get out there and maybe tomorrow morning or tonight, we go do something fun that's off my schedule. I'm in 100%. I'm just going to down regulate a little bit. I'm not going to maybe do as much as you or as hard as you or whatever. I'll do more than I should. But if it costs me tomorrow, it was worth the exchange. I don't have a world record I'm setting anytime soon. I don't have, I got many years. I'm happy to give up a couple of days of exercise to be a little sore that I need to be for the exchange of a lifetime memory. And this stuff is so important to me. This stuff lands as like true lifetime memories. Right? I can look back. Many of my fond memories throughout my life are training sessions with friends, whatever it is, like doing jiu-jitsu with somebody who's a world champion. You're just like, totally, whatever the thing is, right? You're like, that was really, really cool. Absolutely worth missing 2 days. If it's going to be more than 3 days though, where like I'm going to be so wrecked, I can't work out for 5 or 6 days, then I'm probably like, all right, that's kind of nonsense. Unless it's just like an opportunity where I'm like, I absolutely can't pass up, you know? So that's kind of how I think about it. That doesn't happen too often with me though, maybe once a month. And so I'm like, okay, I'm fine, I lost a day. Reality of it is it's probably more like once a quarter that happens. So I don't really care. So you do want to balance joy and life. You don't want to be so rigid about your training program that it ruins and robs us experience. Physical activity should be fun. Your fitness and your training should be something that makes your life better, not some task you have to get done so that 75 years from now, you've hit some metric of who knows what.
Just alone in your room with your training logs.
Yeah.
No, you want
Exactly.
in all seriousness, I think you point to the richness of life, and you can draw these boxes like work, relationships, fitness, recovery, but the boundaries between those boxes are blurry because I should say I love training with people. I greatly enjoyed training with you this morning, not just because I was receiving so many useful tips. In fact, thank you. It's the first time I've PR'd in a number of things today. Yeah. Thanks to your input in the moment. That's an irreplaceable kind of gift, but mostly it's the gift of getting to train with a colleague and friend. So I want to underscore, highlight, and put an exclamation mark behind what you just said. Thank you once again and again for giving us so much interesting, clear, actionable, and at times somewhat counterintuitive information in order to build out an exceptional training program to meet any of, and in some cases, all of the 9 major adaptations that exercise can create toward aesthetic, performance-related, and health span, lifespan, aka longevity goals. There's really a treasure trove of information there. And I look forward to our next discussion about how to best recover from exercise, both within the exercise bout and between exercise bouts, and in the more macroscopic structure of a week, a month, a year. I can't wait.
Yeah, I can't wait either. I love that topic, and I've got a lot to cover, so it'll be fun.
If you're learning from and or enjoying this podcast, please subscribe to our YouTube channel. That's a terrific zero-cost way to support us. In addition, Please subscribe to the podcast on Spotify and Apple. And on both Spotify and Apple, you can leave us up to a 5-star review. If you have questions for us or comments or suggestions about topics you'd like us to cover or guests you'd like me to include on the Huberman Lab podcast, please put those in the comments section on YouTube. We do read all the comments. Please also check out the sponsors mentioned at the beginning and during today's episode. That's the best way to support this podcast. I'd also like to inform you about the Huberman Lab podcast free newsletter. It's called the Neural Network Newsletter, and each month, the Neural Network Newsletter is sent out, and it contains summaries of podcast episodes, specific protocols discussed on the Huberman Lab podcast, all in fairly concise format, and all completely zero cost. You can sign up for the Neural Network Newsletter by going to hubermanlab.com, go to the menu, and click on Newsletter. You provide us your email. We do not share it with anybody, and as I mentioned before, it's completely zero cost. By going to hubermanlab.com, you can also go into the menu tab and go to Newsletter and see some example newsletters from months past. Thank you once again for joining me for today's discussion about fitness, exercise, and performance with Dr. Andy Galpin.